Okay, 5, find the zeros of a polynomial and then enter the domain of the rational function. So I want you to notice that right here we have a polynomial, and then that polynomial is the denominator of a rational function. Okay, so that's how we find the domain, is we look at the denominator and find the zeros. So we're going to take our polynomial and we're going to set it equal to 0 and then solve. And this is great. It's in factored form, which is so nice because then we just set each factor equal to 0. That's why we love when things are factored. I know it's hard to factor, but when everything's in factored form, it's just the opposite sign. I'm writing out the work here. You don't have to if you can just see -3, +8, +9. So those are our zeros. Those are the x values when the polynomial is equal to 0. So what happens if you put these values on a denominator, like say -3, if you put -3 plus 3 on a denominator, that's 0. So these are actually the vertical asymptotes of a rational function. And that means that the graph cannot equal those values. Bad, right? So when we write the domain, we write all values except that. So think of a graph. These values are x equals -3, 8, and 9. We want all values in between. So we're going to go -infinity to -3, pick up union at -3 to 8. Remember, our parentheses means we're just not actually including -3. We're getting really, really close, but we're not including it. And then same thing, union 8 to 9, union 9 to infinity. So we're taking breaks at -3, 8, and 9, because that's where the graph is undefined. So our roots are just those values we just solved. And then domain, you actually have to type in, and all of those values we're going to see twice in our domain. See, I'm going to end with an 8, and then my next one, I'm going to start with an 8. I'm going to end with a 9, and my next interval, I'm going to start with a 9.